Hey everybody, this is Mr. Beckstrom, and today we're going to talk about section 3.5. This is on volume and surface area. So the volume is basically everything that's inside a three-dimensional shape, and we will always use the unit cubed, unless we're actually talking about a unit that is already in a three-dimensional form, like gallons or liters. And the surface area is the area on the outside of this three-dimensional shape. So if we're talking about like a cube, it would be all 6 of the outside faces. Take all of those areas and add them together. So we've got lots of formulas here. This is for a rectangular solid. Let me kind of show you what that looks like here. Okay, this would be a rectangular solid here. And it's really defined by having a rectangle on the 2 bases. That would be the opposite sides. And then the sides are perpendicular to the base. So notice that all of the 4 sides are perpendicular to this bottom base here. And here is the surface area, and here's the volume formula. So let's go ahead and see if you can calculate that now. So go ahead and pause the video and see what you can do, and then unpause it, and we will go over the solution. Alright, so the surface area is really just these 2 rectangles in front and back, the 2 rectangles on the 2 sides, and the 2 rectangles on the top and the bottom added together. Now you can do that manually, but basically they have a formula that does that here. So we just have to decide what the length, the width, and the height are to find the surface area. So you can really call any of them the length, any of them the width, and any of them the height that you want to, because we could really take this rectangular prism and rest it on any of its sides. But for the sake of simplicity, let's call this the height, this the length, and this the width. And to find the surface area, we are going to use our calculator. Alright, so it's going to be 2 times the length times the width. So 2 times the length, which is 40, times the width, which is 10, plus 2 times the length, which is 40, times the height, which is 15, plus 2 times the width, which is 10, times the height, which is 15. And that's it. Just put that in there just like so, just like this formula here. And we're going to get 2,300. So the surface area is going to be 2,300. So the surface area is equal to 2,300. And since we're talking about area, we will take that unit there and we will square it, because inches is not normally an area, so we need to square it to show that we are in an area. Alright, to find the volume is just length times width times height, so we'll do the same thing here. So that's going to be 15 times 40. Doesn't matter what order you multiply them in, because multiplication is commutative. And we're going to get 6,000. Alright, so the volume here is going to be 6,000. And since we're talking about volume, we are going to cube the inches. Cube the inches. Alright, and those are the 2 answers for that one. So let's take a look at a word problem here. Alright, so a gallon contains 231 cubic inches. So they're just giving us a unit fraction. A cylindrical barrel full of juice concentrate has a diameter of 2 feet and is 3 feet high. How many gallons of concentrate are in the barrel? So this is a pretty, I wouldn't say difficult, but a little bit challenging problem here. So if you want to go ahead and try this, go ahead and then unpause the video when you are ready to go through the solution. Alright, so they're asking us how many gallons of concentrate are in the barrel. So this is definitely a 3-dimensional space that we're looking at, so this would be a volume formula. And a barrel could be considered a right circular cylinder, right? That would be a bright circular cylinder. So what I'm going to do is I'm going to first draw out the barrel, and it don't have to be perfect. So kind of open top and bottom here, and I know that the height is 3 feet, and I know that the diameter across the circle base is going to be 2 feet. Now we have 3 different units going on here, right? So we're going to have feet, we're going to have inches, and we're going to have gallons. So we're going to need to do some conversions at the end here. I just want you to keep that in mind. All right, so the volume here is pi r squared times h. So the volume is equal to pi, which is 3.1415, goes on forever, but we can just leave it as pi for now, times the radius squared. Now they give us the diameter of 2 feet, and the radius is half of the diameter. So the radius is just going to be 1 foot. We just divided by 2, and then we're going to square that, and then times the height, which is 3. And that's going to give us, we're going to square this first. So that'll give us 1 times 3 times pi. So that'll just give us 3 pi. And this is going to give us feet cubed. Feet cubed. So we do have the volume, but we have it in terms of feet cubed, and we need to get it in terms of gallons. So we're going to need to do some conversions here. So remember, we always start with our known amount. So 3 feet cubed, 3 pi feet cubed. And the first one, we want to get rid of the feet cubed. So I'm going to try to convert that. I don't know how many cubic feet are in a gallon, but I can figure out how many cubic feet are in a cubic inch. So I can convert between cubic inches and cubic feet, because I know that there's 12 inches in 1 foot. So in order to find out, since this is cubed, I have to cube that 12 to figure out how many cubic inches are in 1 cubic foot. So if I go to my calculator here, since I'm going from inches cubed to feet cubed, I have to take the 12 and multiply it by itself 2 times. So 12 times 12 times 12, or 12 to the third. So that tells me that there's 1,728 cubic inches in 1 cubic foot. So 1728 cubic inches in 1 cubic foot. And then I'm going to multiply that. Now I want to, remember I got rid of my cubic feet, so now I want to get rid of my cubic inches. And the problem told me that there are 231 cubic inches in a gallon. So going back up here, there are 231 cubic inches in 1 gallon. Now you may say, how come you put the cubic inches on the bottom? I did that because I don't want the cubic inches in my final answer, and I want them to cancel out with the cubic inches up here. So that's why I put them on the bottom. If I put a 1 over here, and then I just multiply those fractions together, on the top I'm going to get 3 pi times 1728. And on the bottom I'm going to get 1 times 1 times 1, which is 231. And this is going to be approximately equal to, I'm going to put this into my calculator now. So 3 pi, if you have the pi button you can use that. If you don't, you can use 3.14 times 1728. Hit enter, and then we're going to divide that by 231. And I'm going to get approximately 70.5 gallons. So approximately 70.5, and I think they use GAL instead of just G, but it doesn't matter for this. So this would be my final answer. So there's approximately 70.5 gallons of concentrate in this barrel. All right, let's take a look at another example here. Okay, so this one says here that the Earth has a diameter of approximately 7,920 miles and a volume that is roughly 49 times the volume of the moon. All right, find the diameter of the moon. Wow. So, all right. So, let's go ahead and try to draw some pictures here and see what we're looking at. So we are first given the diameter of the Earth. So that is, let's just kind of draw I don't really know how to draw a cube here or a sphere too much, but this is going to have a diameter, so that's a distance all the way across here, of 7,920 miles. I didn't write that very well. And its volume is roughly 49 times the volume of the moon. Find the diameter of the moon. Alright, so let's go ahead and write the moon here. It's going to be much smaller than that, but this is what we're trying to find here. So go ahead, pause your video, see how far you can get, and then we will go through a solution. Really large numbers, so we're going to have to make it a little bit clever with our solution. So I'm going to go ahead and set up the equation here, and I know that the volume of a sphere is 4/3 times pi times r cubed. So I'm going to set up that equation. I know that the volume of the Earth is roughly 45 times the volume of the moon. So I'm going to set that up as kind of an equality here. So the volume of the Earth is going to be, just a moment here, 4/3 times pi, I'm just using this formula down here, times the radius. The radius is going to be half of that diameter there. So I'm just going to do 7,920 divided by 2. And I get 3,960. So it's going to be 3,960 cubed, right? So here is the volume of the Earth, and now I want to put the volume of the moon using this same formula. Equal to, remember, it's 49 times the volume of the moon. So 49 times the volume of the moon. So that's just going to be this formula here. We don't know the radius of the moon, so we're going to leave that as a unknown there. So times 4/3 pi times radius cubed. Alright, so how do we solve this? Let's already X this out. I'm going to have a 4/3 pi on both sides here, so I can cancel those out. And then I just have the 49 here. So what I'm going to do is I'm going to do the radius cubed is equal to, and I'm going to divide both sides by 49, so I'm going to get 3,960 cubed all over 49 like this. Alright, so there's a couple different ways to do this, but I'm going to let my calculator do this. So I'm going to calculate this amount here in my calculator, and then I'm going to take the cube root of it in order to get r by itself. Alright, so follow along here, but what I'm going to do is I'm going to take the 3,960, we're going to cube that, and then we're going to divide it by 49 to get a really big answer, and then I'm going to take the cube root of it. That's kind of like the square root but for cubes. And to do the cube root, you take that answer there and you take it to the exponent 1/3. That's how you can do a cube root in your calculator there. And I'm going to get 1,082. And then, since that's the radius, I just need to double it to get the diameter. So times 2, and I'm going to get about 2,164. So the radius is, well, this would be the diameter. The diameter is approximately equal to 2,164 miles. And this would be the diameter of the moon. So that was a lovely one. So let's go ahead and call it here. Try some of these examples. I know that a lot of them are pretty difficult, but make sure you ask me any questions that you have, and I hope you have a great rest of your week. Thanks.